All right, I'm going to actually ask you how to graph. I'm going to have you graph by hand, actually sine and cosine. And as we get further on, we'll do tangent, secant, cotangent. We'll do all of them. But we're going to start off with the basic ones. We have f of x equals sine x. And then we have g of x equals 3 times f of negative 1/2 times x plus 2 minus 4. So this is our generic notation for transformations. What we need to know about the parent function is the general shape. Well, I know my general shape of a sine wave looks like this. And I also need to know some points. So when I do x, and I'm just going to put y. We're going to do our mappings. But I need these points right here. So I'm going to pick my x-intercepts, and I want to pick my maximum and minimums. And I'm going to do one period. So I'm going to do 0, pi over 2, pi, 3 pi over 2, and 2 pi. So sine at 0 is 0. Sine at pi over 2 is 1. Sine at pi is 0. Sine of 3 pi over 2 is negative 1. And sine at 2 pi is 0. You should have those memorized from the unit circle by now. Now we're going to do transformations on this, so we need to set up my mapping. Well, this is easy enough. We know that the a and my d goes with my y, so we do 3y minus 4. And on the inside, now we have a b this time. It's one of the first times you're going to have to deal with a b. So a b is going to be opposite of what you think. So inside the f is still the same. It's opposite. So I've got a negative 1/2. That means I want to multiply by 2x, and I've got a plus 2 and a minus 2. And that's all I'm going to do. So from here, I'm just going to plug in my values. This becomes negative 2. Let's see, this becomes, what is this, negative pi minus 2, and I'll get a decimal for that here in a second. This gives me negative 2 pi minus 2. This gives me negative 3 pi minus 2, and then this will give me negative 4 pi minus 2. And I'll get a decimal for these in a second, because I couldn't tell you exactly where these are on the graph, but when I have a decimal, I can. Over here, I plug them in. This gives me negative 4. This gives me negative 1, negative 4, negative 7, and negative 4. All right, so from here, I'm just going to pop up a calculator, get decimal approximations. So we're going to do, let's see, negative 2 is pretty straightforward, but we need to do negative pi. So negative pi minus 2. Hit enter. I've got a, so this is about negative 0.5, no, negative 5.1-ish. Then I need to do a negative 2. Negative 2. Hit enter. It's about negative 8.3. Then do a 3. Negative 11.4. Dag nabbit. Do a 4. And this is a negative 14.6. So all I have to do to graph this is plot the points. So let's plot. So I'm kind of in the way, plotting right in front of me. So let's see, I've got a negative 2, negative 4. Let's call that negative 2, negative 4. Negative 5.1, negative 1. Negative 8.3, negative 4, so it's back on this line. Negative 11.4, negative 7, and then back up here. So that would be my graph for one period. So not terribly bad. You can label the points. You don't have to be precise if I ask you to graph it. Just kind of give me a rough sketch of it. So yeah, regular transformations. The only thing that changed was my parent function, everything else still works the same. Hi, I'm Mr. Buzzard, and these videos are supplemental instruction for my students. If you found the video enjoyable, make sure you click the like button and click subscribe, as well as the bell for notifications to receive future videos on high school mathematics.